In these problems, we're dealing with triangles. We're finding areas, and we're also using something called the Pythagorean Theorem to find sides in right triangles. The first question here says, what is the area of the right triangle and what is the unknown side? Well, let's start with the area. Remember, the formula for an area of a triangle is 1/2 the base times the height. When you have a right triangle, the height is this other side. And actually, if you think about it, this is really half of a rectangle with sides 27 and 36. So when you say 1/2 base times the height, it's really 1/2 of these two sides of this rectangle. And that makes sense that that would be the area. To calculate this, we just plug in our numbers into the formula. So this is 1/2 times 36 times 27. So you might punch into your calculator 36 times 27 and then divide by 2. And if you do that, you should get 486. And they didn't give us any units here, so I'm not going to worry about writing them down. If I was going to write down the units, though, I'd have square units because that's area we just figured out. Now, they also want us to figure out this missing side, and they've got it labeled as A, which I think is a little confusing because usually when you look at a right triangle, the convention is to say the shortest side is A, the next side is B, and the hypotenuse, this long side that's opposite of the right angle, is C. And that's important if you're going to use the Pythagorean theorem to know which side is the hypotenuse. So I'm actually going to cross this A out and put a C there, just because I think that's less confusing. Now the Pythagorean theorem says A squared plus B squared equals C squared. And what this really means is that you take these two sides that aren't the hypotenuse, you square them, you add them together, it equals the hypotenuse squared. So if we're trying to find C here, what I can do is plug in 27 for A, 36 for B, and then I can solve for C. Let me show you how that's done. So 27 in for A, so A squared becomes 27 squared. 36 in for B, so B squared becomes 36 squared. And then we're looking for C, so C squared stays the same. Now 27 squared is 729. You can get that on your calculator by punching in 27 times 27, or just 27 and then the x squared key. 36 squared is 1,296. Now I'm going to add these together, so 729 plus 1,296, and I get 2,025 equals C squared. But I'm not done. This is what C squared equals. So after I add these together, what I have to do is take the square root. It's like I'm taking the square root of both sides. If I take the square root of C squared, I get C. If I take the square root of 2,025, I actually get 45. And C equals 45. And if I look back up at my picture here, that makes sense because the hypotenuse is supposed to be the longest side. And I've got sides of 27, 36, and now 45. So that looks pretty good. All right, let's look at this next problem. This one says, what is the perimeter of the triangle? And that means I have to add all the sides together because I'm walking around the outside and I want to know that total distance. And then they're telling us to round to the nearest tenth. Now here, I like the way they've labeled it. They've got this C, and this is the hypotenuse. Even though this triangle is sort of turned upside down a little bit, it's the side that's opposite the right angle. So I know that's the hypotenuse. So I can use my Pythagorean theorem, A squared plus B squared equals C squared. And I'm going to start subbing in my numbers. So A is 2, so that's 2 squared. B is 4, so 4 squared equals C squared. So once again, I'm going to add these together now, and then I'm going to have to take the square root. So 2 squared is 4, 4 squared is 16, 4 plus 16 is 20. So C squared is 20. That's not what C is, that's what C squared is. If I take the square root now, I get C equals, and that's about 4.47 or so. So not exactly, but about. Now the perimeter is all these distances added together. So it would be 2 plus 4 plus 4.47. If you add all those together, you would get 10.47. They wanted this rounded to the nearest tenth, so I'm going to call this 10.5. And that is the perimeter of that triangle. Let's try one more. All right, now this is a tricky one because we want to use the Pythagorean theorem to find x over here, and x is not the hypotenuse. The hypotenuse is this one. It's opposite the right angle. So when I put out my theorem here, a squared plus b squared equals c squared, I'm actually going to put a 34 in here for c. I can put the 16 in either for a or b, it doesn't really matter. I think I'm going to put it in for a. And then this value here, I'm just going to leave as b. So let me set this up with the numbers. A squared becomes 16 squared. B squared, I'm just going to leave as it is. And then c squared is 34 squared. So let me do the squaring here. 16 squared is 256. And 34 squared is 1,156. Now, I've got to do two more things to solve for b squared. First of all, I need to get rid of this 256 over here. So I'm actually going to subtract it from both sides, doing a little bit of algebra here. Once I do that, 256 minus 256 over here, that's 0, so I can just get rid of it. It just leaves the b squared on this side. 1,156 minus 256 is 900. Now I've got b squared equals 900, so I can take the square root of both sides. The square root of b squared is b, and the square root of 900 is 30. So it turns out that side is 30. So that's a little bit about triangles and using the Pythagorean theorem. My name is Larry. I'm a teacher at EdVisions off campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethischool.org. Thanks.